All right, today we're becoming cosmic detectives. We're on the hunt for a suspect so powerful, so massive, it literally bends the fabric of space and time. We're talking about a true ghost in the galactic machine. So here's the big question. How on earth do you weigh something you can't see, especially when it's billions of times heavier than our own sun? I know, it sounds totally impossible, right? But stick with me, because the way astronomers pulled this off is, honestly, one of the cleverest things you'll ever hear. So every good mystery starts with a scene of the crime. For us, it's a huge galaxy way out in a cluster called Abell 121. We're talking billions of light years away. And on the surface, it looks pretty normal, for a giant galaxy. But there's something hiding there, something massive. And this was the first clue. As astronomers were looking at images from the Hubble Space Telescope, they saw this giant, glowing arc of light right next to the galaxy. Now, that arc is actually the light from another galaxy, one that's even farther away, behind Abell 2101. And its light is being stretched and smeared into a curve. That's just not supposed to happen unless something with an absolutely incredible amount of gravity is in the way. Okay, so how does a weird smear of light turn into evidence? Well, it all comes down to one of the most fundamental ideas in all of physics, something Albert Einstein himself figured out. It's the key that lets us see the unseeable. The tool is called gravitational lensing, and the idea is pretty mind-bending. Anything with a ton of mass doesn't just pull on things nearby. No, it literally warps the fabric of space-time around it. And light, which we think of traveling in a perfectly straight line, has no choice but to follow those curves. So, in effect, a massive galaxy acts like a giant cosmic magnifying glass. Let's just walk through it real quick. So, you've got light from a super distant galaxy traveling for billions of years towards us. On its way, it has to pass by our foreground galaxy, Abell 1201. The insane gravity from Abell 1201 creates this huge dip in spacetime. The light follows that dip, gets bent, and by the time it reaches our telescopes, what we see isn't a little dot of light, but this beautiful, stretched out, magnified arc. And here's where the detective work really begins. Because if you can measure the exact shape of that arc, how much it's bent, how bright it is, you can actually work backward. You can build computer models to figure out exactly how much mass and where that mass must be to create the exact image you're seeing. Now, this is not easy. It is painstaking work. It's like trying to figure out what an object looks like based only on its weird, distorted shadow. Every single detail of the computer model has to line up perfectly with the real image from Hubble. If it's off by even a little bit, the whole thing falls apart. So the team came up with two main suspects, two different models. Let's call them Suspect A and Suspect B. Suspect A says, okay, the gravity we're seeing is all from the visible stars in the galaxy, plus the giant halo of invisible dark matter that we know is there. But Suspect B adds one more thing to the mix, a huge, supermassive black hole hiding right in the galaxy's core. So how do you choose? Well, you run the numbers. They used some pretty advanced statistics to see which model was a better fit for the evidence. And just look at the scores. The model without a black hole scores 125,598. The model with the black hole scores 125,699. Now, I know that doesn't look like a big difference, but in statistical terms, this is an absolute slam dunk. It's basically the universe telling us that the black hole model isn't just better, it's the only one that makes sense. And here's why. The model that was missing the black hole, it just couldn't quite get the image right. When they ran the simulation, there were these leftover blurry bits of light that the model just couldn't account for. It was the scientific version of a key piece of evidence that just doesn't fit the story. But the moment you add the black hole to the model, everything snaps into place. It explains the light perfectly. Case closed. So with the evidence pointing to one thing and one thing only, it was time to really figure out what they'd found. And the answer was just staggering. This wasn't just some run-of-the-mill supermassive black hole. The model showed that the culprit hiding in the center of Abell 1201 weighs in at over 30 billion times the mass of our sun. Let that sink in for a second. Billion with a B. That number is just almost impossible to wrap your head around. A number that big puts this object into a very, very exclusive club. It's officially what's known as an ultramassive black hole. We're talking about one of the true heavyweights of the entire cosmos. It's one of the biggest ever found with this lensing technique. But finding this one monster is about more than just this one galaxy. See, this case connects to a much bigger mystery, a kind of cosmic conspiracy about how our entire universe came to be the way it is. And this chart just puts it all into perspective. Look on the left. That's the black hole in our own galaxy, Sagittarius A star. It's about 4 million times the mass of the sun. Pretty big, right? Now look at Abell 1201. At over 30 billion, it just completely dwarfs it. It's playing in the same league as TON 618, which is one of the absolute largest black holes we know of. These things are just an entirely different kind of beast. And that's really why this is so important. Finding these ultramassive black holes helps us tackle the biggest questions out there, like how did they get so huge, so fast? Our current theories have a really hard time explaining it. It's like they skipped a few steps. By finding and weighing these giants, we get the crucial data we need to figure out what's really going on with the evolution of galaxies. So, by following a trail of bent starlight, we've managed to weigh a ghost. This amazing technique is opening up a new way to find these invisible titans all across the universe. And it really makes you wonder, doesn't it? What other secrets and what other, even bigger ghosts are still out there, just waiting for us to see the shadows they cast?